Hello people, welcome to Code Framer. In this video, we are going to look at some examples to explore Python numbers. Before this video, I recommend you to go through Python data type part 1 video, so that you understand the conceptual part of this data type. I have given the link of that video in the I button and also in the description. I am going to use the Jupyter Notebook editor in this video. This is probably the best terminal and editor available for Python developers. It is so helpful for script writing, troubleshooting bugs or errors, algorithms design, and especially machine learning and artificial intelligence related algorithms design. I will create a separate video in future to show its installation steps. But, for now let us focus on Python numbers data type. Let us first understand how a Python interpreter treats or reads different numbers. What are the different operations that we can perform on numbers in general? First I will perform basic mathematical operations on numbers. So, if we add 2 plus 2 and execute, it gives us the result as 4. Note here, that I am not giving any print command. This is because the interpreter will automatically print the result of a mathematical expression. Similarly, subtraction, multiplication, and division is possible between any two numbers in Python. So, let me try a little more complex mathematical expression. For example, 60 minus 4, multiplied by 10. Here the interpreter will have to follow the mathematical precedence to perform the calculation. You must have read about precedence in your mathematics class in school. But just in case if you are unable to recall, in any mathematical expression, first the exponentiation is performed, then multiplication, the division, then addition, and finally subtraction is performed. This is the order in which calculation is done over an expression. Python interpreter will follow this exact rule. Hence in this expression, first, 4 will be multiplied by 10, which will result in 40, and then it will be subtracted by 60. The result will be 20. Any expression inside the curly braces will be given highest precedence. So, if we say, 60 minus 3, multiplied by 10, and put it inside the curly brace, and then divide this by 5. Then what do you think will be the result of this expression? The interpreter will find the curly braces, and it will first calculate the value inside it. So, first multiplication of 3 and 10, will result in 30, and it will be subtracted by 60. The result will be 30. And finally, it will be divided by 5. The final result will be 6.0. Notice here, that we got the result as a floating point number, even when we were dividing two integers without any decimal points. This is because, the division operation will always return a floating point or decimal number in Python. Let me give another example. 9 divided by 4 will give the result as a floating point number, which is 2.25. And similarly, 22 divided by 7 will give a large floating point result. As you must know, that there is no end to the fractional part of this division. But, the Python interpreter goes maximum up to 15 digits in the fractional part. I hope that this is clear. Let us explore some more mathematical operations with Python numbers. We can find the quotient of a division by using the double slash symbol, which is also known as floor division. For example, if we say 16//3, then the result will be 5. Because here, the quotient is 5, and the remainder is 1. Now, if you want to find the remainder of the same expression, then we can use the modulus operator, which is the percentage symbol. So, if we say 16% 3, then the result will be 1. Because when you divide 16 by 3, then the remainder is 1. I hope that this is clear. The floor division and modulus operator are very helpful to solve many algorithms. So I would recommend you to practice more. To test your understanding quickly on precedence, try to solve this expression with correct operator precedence. 4 multiplied by 3, plus 4. What will be the result here? It will be 16. Because, first multiplication will be done, and then the addition. I hope that the precedence concept is clear. Python also supports the exponentiation operators to find the result of power of any number. The exponentiation operator is denoted by two asterisk symbols. So, for example, if we want to find square of 6, then we can say 6 **** 2. This will give the result as 36. Similarly, if we want to find result of 4 to the power of 4, then we can say 4 ***4, and the result will be 256. I hope that by now it must be clear to you on how the Python interpreter treats the numbers. Just play around a little more, and execute some more complex expressions yourself. Let us now move to a few other things about Python numbers. We can store numbers in variables, and perform different mathematical operations using those variables. If we store a value of 20 in variable A, and then we store value of 30 in variable B, then we can perform any mathematical operation with these two variables. So for example, if we multiply them, then it will give the result as 600. Similarly, you can perform addition, subtraction, and division on these two variables. I hope that this is clear. Explore different mathematical operations after storing numbers in variables. Now let me talk about typecasting in Python. In the last video, I explained the conceptual part of typecasting in Python. If you have not seen the last video, then I would highly recommend you to watch it. The link is in the description. As the typecasting is automatic in Python, you can write mathematical operations, which contain both integer and floating point numbers. But remember, that in such cases, the result will be in float data type only. For example, 4 is multiplied by 3.14, and then added with 22. The result will be 34.56. Here, when 4 is multiplied by 3.14, then the result is a floating point number, 12.56. Now, when 12.56 is added with 22, again the result is a floating point number. So as a generic rule we can say, when any mathematical operation is performed with floating point numbers, then the result will always be in float data type. If you have a C or Java background, then you could imagine that this was not possible there, without defining data types, and also type conversions. But Python interpreter does it by itself. Now, does that mean manual typecasting is not possible in Python? Not at all. It is very much possible. Before understanding type conversion operations in Python, let us first understand how we can see the type of number. You can see the type of any number using the built-in type function. For example, the type of the following numbers are integer, float, and complex numbers. Notice that the interpreter is showing the type of numbers as a class object. But don't worry about class at this point of time. I will explain it during object-oriented programming. Now, let me quickly give examples of integer, float, and complex numbers data types. As you can see in this example, in Python 3, single-digit integer, large integer values, and negative numbers belong to integer data type. Similarly, decimal numbers, with single or multiple fractional parts, and also negative decimal numbers, belong to float data type. I hope you remember that in the last video, I talked about numbers with scientific notations, that are also possible to store in Python. Following are some quick examples. As you can see, all the numbers with scientific notations are of float data type in Python. Next one are complex numbers. The Python interpreter reads any complex number as a complex number data type. Following are some examples. Now, let us do some type conversions to understand manual typecasting in Python. Let us initially store an integer value, float value, and a complex number value in different variables. Let us first convert the integer value to float by using the built-in function float and passing the variable x as the argument. The result will be stored in variable A. Similarly, let us convert the float value in variable y to an integer by using the built-in function int. And finally, let us convert an integer value to a complex number by using the function complex and passing x as the argument. As you can see in the result, the values are converted to corresponding data types. You can use these converted data types to build different logic based on your requirements. This is how manual typecasting can be performed in Python. I hope that these concepts are clear. I would highly recommend you to play around more with numbers in Python. See what else you can do with numbers. Spend some time getting familiar. In the next video, I will explain about Python strings in the Jupyter Notebook. Support us by liking this video and share it with other code lovers. Subscribe us for future notifications. We'll see you soon in the next video, and until then, happy learning.